All right, this is the Math 7 integer addition and subtraction test review. This means we have a test coming up, and this is our last day to practice before we take that test. So, I'll say it once and I'll say it again at the end. Anything we don't finish in class is homework. So, should you always be using your time wisely? Even if I finish doing a certain kind of problem, could you be moving on to the next one? Yes, because this is a review. You've already learned everything that you need to know. You're just reviewing. The problems on your test are a lot like the problems here on the review. So you need to know how to do each kind of problem, and this is your last chance to get those questions answered before it's too late. Okay? So with that in mind, I need you to discuss with your group what are the directions. What are we even supposed to do with these kinds of problems? And then you can discuss the answers. Pausing the recording as you discuss. Ready, set, go. What am I even supposed to be doing for these problems? What do the directions say? Don't just read the directions. What does it mean? Andrew. Nope. Write an integer doesn't mean explain. And that's why I'm glad we're making sure we read the directions and understand what those directions mean. When it says write an integer for each situation, what does that mean? Tanner? I could write a whole number, but what if it is something like 307 meters below sea level? Does writing a whole number work there? What should we write? A negative whole number. Remember what integers are. Integers aren't just whole numbers. They're whole numbers, negative whole numbers, and zero. So we do need to make sure that we understand what an integer is. So, if it's a withdrawal of $40 from an account, what number, what integer am I going to write to represent a withdrawal of $40? Kale. Negative 40. Why negative? Exactly. I'm taking away from the bank. I am taking money out of the bank. That's what a withdrawal means. And negative shows that we're taking it away. Notice what's happening here. Am I using a dollar sign? No. Because if I use a dollar sign, that's math practice too. That makes it quantitative. When I want an integer, that means I'm abstracting it. I only want an integer, only a number, no units of measure. What about number 2 then? A deposit of $184. A deposit of $184. What does that mean? I should see way more hands right now. The fact that I'm not seeing hands means you're probably off task. That's better. Aaliyah. Yep, a positive 184. Why is a deposit a positive number? Deposit, positive. Why? Gabriel. Yeah, we're adding more in. Exactly. We're adding more into the account. Whether it's coming from my wallet and I'm putting it in the bank account, or it's coming from the school because the school is paying me, so it's coming into my bank account. It's extra money in the bank account, so that's a positive. Okay, number 3. 372 meters above sea level. Let's go to Michael. 372, and it would be positive because it's above sea level. And 17 feet below sea level. 17 feet below sea level. Riley. Yeah, why negative? Because it's below. Exactly. Below is negative. Borrowing $23 from a friend. Borrowing $23 from a friend. This one had some good conversation in our last class. What do you think, Seth? Good. Why is it negative 23? Because my last class thought it should be positive. Because if we borrow money from a friend, isn't that more money that I have now? So why would it be negative 23? John? Exactly. We're going to have to pay it back. This is a different situation than a friend giving you $23, right? A friend giving you 23, that would be a positive. But borrowing 23 from a friend means that eventually I'm going to have to pay her back. So I would say that's a negative 23. Good job. And 12 degrees below zero. 12 degrees below zero, Brooklyn. Negative 12, exactly. Notice on any of these, did I put degree signs or feet or dollar signs? No, I don't want those units. Because all I want for these problems is just an integer. Maybe write a note there. Just an integer means don't worry about units. I know that's backwards, right? Normally we want units, but this time I just want numbers. The next are some really great ones to practice, and I'm going to be honest with you. My last class who took this test, my honors class, they struggled with these kinds of problems. Let's see if you guys can do better. Okay? Review these now. 9 through 12, review those with your groups. Ready, set, go. Find the value of each expression. What is that weird symbol with the straight lines? What does that mean? How do I even say that? I say, you know, the weird straight line thingies with the 7 inside, right? That's how I say it? No? How do I say it? Bridger. It is called absolute value. So I would say the absolute value of 7. When I say the absolute value of 7, what am I thinking? What does that mean? Absolute value of 7, what does that mean? Let's go Brooklyn. Yes, how far away is 7 from 0? So, how far away is 7 from 0? On this one, 7 is 7 away from 0. And this one, absolute value of negative 12. How far away is negative 12 from 0? Tanner. It is 12 away from 0. What am I supposed to do here on 9 through 12? All right, how do I do 9 through 12? Go ahead, John, explain it to me. Good. I'm actually glad that you said that because you did make a mistake, and we can learn from that mistake. You did, because you said we're going to add them together, which is true, but we have to add them together following the order of operations. Remember, this is a grouping symbol, so I need to do the grouping symbol. So I have the absolute value of negative 5, which means I have to do that grouping symbol, I have to do the absolute value, and then I'm adding, we have another grouping symbol, so I have to do that grouping symbol first. So, what is the absolute value of negative 5? How far away is negative 5 from 0, John? It is 5 away. And how far away is 11 from 0? 11. And what's 5 plus 11? 16. Did you say 6 before? Okay, so we see what our mistake is, right? We can learn from that. Please compare number 9 to number 11. And I know they're different numbers, but will you just see what is that big, huge difference between 9 and 11? Talk with your groups real quick. Real quick. What's that difference there? Happy to see all of these hands. Bridger? There's 4 lines, right? But that means there's 2 separate absolute values. How many absolute values here? 1 absolute value. So we have to handle that a little bit different, right? Remember, it's still the order of operations. We have grouping symbols, which means I need to do what's inside of the grouping symbols first. What's inside of the grouping symbols? Negative 7 minus 2. What's negative 7 minus 2? Your model would be really good here. I have 7 rocks. 1, 2, 3, 4, 5, 6, 7 rocks. I need to take away 2 balloons. Do I have balloons? Nope. So turn into Dora. Get out those 0 pairs from the backpack. Now, can I have balloons? Or now do I have balloons that I could take away? Yeah, remember, these are just zeros. They're just 0 pairs. But now I do have some balloons that I can take away. And when I take away those balloons, what do I have now? 1, 2, 3, 4, 5, 6, 7, 8, 9 rocks. So this part right here simplifies to negative 9. Now I can continue on. Oops. Now I can continue on. What is the absolute value of negative 9? Why, that's 9, because it's 9 away from 0. Do you see the difference between those? Here we had to do the absolute values first and then add, because we did our grouping symbols first and then we can do addition. Here we had to do what's inside of the grouping symbol, which means we had to do that subtraction, then we can move on to absolute value. Please fix numbers 10 and 12 if you need to. 10 and 12, fix those now. Do them at home for homework if you haven't done them already. I'm going to move on to the next set of problems. Here's the next set, 13 through 24 on the backside. Just lots of practice there. You can draw models if you need to, balloons and rocks, chip tiles, number lines if you want to. I want you to work on those ones now. Going to pause the recording, give you a chance to get some of those done. Ready, set, go. All right, I am not going to show every single answer here, but I'm going to show a couple. 13, 14 plus a -8. I'm thinking of this as 14 balloons and 8 rocks. I'm going to have a bunch of 0 pairs. The answer here is 6 because there's 6 balloons left over. Here, I have 5 balloons and I'm adding 11 rocks. Again, balloons and rocks, some of them are going to be 0 pairs. I'm going to have 6 rocks left over, so the answer is -6. Again, I'm not showing the answers to all of them, just to some of them. Let's go down to number 18. This is 3 balloons, take away 8 rocks. If all I have are balloons, I can't take away rocks. But that's when I remember taking away rocks makes the basket go up. I can make the basket go up by adding balloons instead. So I can change the problem and have the same result. Taking away rocks makes the basket go up. Adding balloons makes the basket go up. And 3 plus 8 is a lot easier. 3 plus 8 is equal to 11. Number 19. I see the same thing that I saw over here. I can change minus a negative to plus a positive if I want to. But I also know that this is really 9 rocks. Take away 17 rocks. If I have 9 rocks, do I have enough to take away 17? No. So maybe I do want to make that change. If I had enough, maybe I didn't have to make that change. But since I don't, let's make that change. This is going to then change. Taking away rocks makes the basket go up. I'm going to change this to an add balloons problem. Now, I have 9 rocks. I'm adding 17 balloons, so I don't have to worry if do I have enough or not because it's just an addition problem. So 9 rocks, 17 balloons, that means I'm going to have a bunch of 0 pairs, and I am going to be left with 8 balloons. 24, I've already given you the answer, so let's talk about 24. Do you see that? No. It said -14 minus a -4. That is the answer. That shouldn't be there. Oops. But -14 minus a -4. This is one where I can say, hey, this is 14 rocks. Take away 4 rocks. If I have 14 rocks, do I have enough that I can take away 4 rocks? Yeah. 14 rocks take away 4 rocks is going to be 10 rocks, which is represented by the integer -10, which was already on your paper. Okay. And now we're going to switch our attention to some stories because stories are a big part of your test tomorrow. This is a lot like what we did last time with 2.1f, our integers in context. For each problem, we're going to write a numerical expression that's like a number sentence that models the situation, and then write a complete sentence stating your answer. Drawing pictures as needed really help us make sense of the problem. So, number 25, an undersea diver is 13 feet below sea level. She swims down another 5 feet to inspect some coral. What is her final position? To really help me understand that, I'm going to draw a picture. Here's my water. Here is my perfect undersea diver, and you guys aren't going to be able to judge this at all because it's going to be so perfect. She's even wearing a mask, and she's got her little oxygen tank. Do you see her little flippers too? Those are good, huh? Perfect, perfect undersea diver. And where is she? She is 13 feet below sea level. That means I need to be representing that with a -13. So what's her position right now? -13. But what's happening in this problem? She's going further down, right? How much further down is she going to swim? 5 feet. So we're going down another 5 feet. My picture really helped me understand that. It wasn't a chip or tile model. It wasn't a number line, but drawing a picture did help me understand it. I need to write a number sentence. Where is the diver starting? At -13. She swims down another 5 feet. Since she's going down, I'm going to show that with -5. You could also, this one, it doesn't matter for this one. You could show it as -13 plus a -5. Both of those would be acceptable. Where is she now? No matter which way you do it, she is at, and the picture really helps, -18. And now the sentence. She's at -18, but what does that really mean for the story? She is at 18 feet below sea level. Next one. This is the biggest problem that my last class missed on their test. Let's see if you guys can do better. I'm going to pause the recording and let you guys give it a try in the beginning. Remember all the things we need to do. We need to write a number sentence. We need to write a sentence, a complete English sentence stating the answer. Pictures and models might help. So number 26 with your groups. Pause the recording, ready, set, go. Number 26, Jackson lives 6 blocks south of the school and Ethan lives 5 blocks north of the school. How far apart do they live? The picture that I'm going to draw is a school that's going to look like a house. On a map, where is north? Up, exactly. So I'm going to show Jackson lives, Ethan is the one who lives 5 blocks north. So showing up 5. And Jackson is the one who lives 6 blocks south. So if north is up on a map, south is going to be the opposite, down. So if it's the opposite, can I just say 6? No, because it's the opposite, so it has to be -6. So this is where it gets to be tough writing that expression. Because we can see how far apart they are, right? Here's 5 bunny hops to get down to 0. 6 more bunny hops to get down here. So we know that they're 11 apart, but how do I show that? Because if I just say 5 plus 6, does that take into account that this was negative? So how am I going to show that? Any ideas? It's right here. How far apart? I'm asking what is the difference? What kind of a problem should this be? Riley? Subtraction. Difference means subtraction. So, how am I going to show this? 5. Oh, I'm going to do that in yellow because it's positive. Positive 5 minus a -6. What does minus a negative end up being? Works the same as adding a positive, right? It works the same, so I know that it's going to be 11. But now I'm taking into consideration, I'm asking how far apart, and I'm showing that that south direction was a negative number. And the complete sentence, they live 11 blocks apart. Number sentence, complete sentence stating the answer. On the first day of winter, early in the morning, the temperature is -7 degrees. That afternoon, the temperature has increased by 18 degrees. What is the temperature that afternoon? Pause the recording to give yourself a chance to do this. And let's go over it. I know that happened really fast in class, but we're running out of time. So we're doing it. Okay. How cold is it in the beginning of the problem? -7. What's happening? It's increasing by 18. So exactly, I think that's a pretty easy one to do real quick, right? It's at -7, but it's increasing. That means I'm adding. How much am I adding? 18. Draw a model if you need to. -7 plus 18 is equal to, anyone know? Gabriel? We'll come back. Michael? It is 11, yep. So what is the temperature that afternoon? 11 degrees in the afternoon. The temperature is 11 degrees in the afternoon. I'm not going to go over 28 and 29 in class. You guys can do those ones for homework. let's do the last ones together here. I'm only going to do 30 and 31, and you guys get to do 32 through 35 for homework. 30 and 31. Will you please quickly take a look? Aren't 30 and 31 really similar? But they are different problems, right? So the way that we model them is going to be different. Go through those processes as you ask these questions, because for each one of these, we need to draw a chip tile model and a number line model. Where's the basket? Where are we starting? What's in the basket here? Ooh, that's a positive 4. So that's going to be 4 balloons in the basket. What am I doing in this problem? I am adding. What is it that I'm adding? -9, so that's 9 rocks. So let's go ahead and just add in 9 rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9. What happens when I added in those rocks? Oh, look it. We created some 0 pairs. So knowing that those are all 0, what do I have left now? 1, 2, 3, 4, 5. But they're all negative, so -5. Let's show that same stuff on a number line. We have to first go from 0 to 4. And now we have to go in the negative direction 9. So starting where I left off, 1, 2, 3, 4, 5, 6, 7, 8, 9. Where did I end up? At -5. Just like I ended up with -5 or 5 rocks, I got the same answer each time. But now let's switch to the new problem. This is 4 balloons, so I'm still going to start with my 4 balloons. I'm going to draw those to begin with. And this problem says take away 9 rocks. Do I have rocks here to take away? No. So it's time to turn into Dora, right? Oh no, we have to look at our 0 pairs. So here's a balloon and here's a rock 0 pair. Do I have a rock now? Yes. Do I have enough? No. So I'm going to keep on drawing some 0 pairs, which I'm going to draw with technology. There's 2, 3, 4, 5, 6, 7, 8, and 9. Do I now have enough rocks that I can take away 9 rocks? Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9 rocks gone. With all those rocks gone, looks like I have only balloons left. 1, 2, 3, 4 balloons plus 5, 6, 7, 8, 9, 10, 11, 12, 13. Wow, I've got 13 balloons, so a positive 13. We also model subtraction differently on our number lines too. I'm starting with 4, so I need to put a dot on 4. And I'm taking away, I'm finding the difference or the distance between that one and -9. Where's -9? All the way down here. And looks like here is the left number and here is the right number. Where am I starting? On the right, yeah, starting on the right at 4. Start on right. And if I start on the right, that means the answer is going to be a positive number. How positive is it? Let's count those bunny hops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13 again, just like I got the last time. 13 bunny hops. And again, you get to complete those as homework. So anything we have not finished in class is homework, including any of these that you did not finish. That's it for watching, or that's it for today. Thanks for watching. Have a good one.